Alright, this is lesson 2 from Unit 4 on rational equations, and in the second lesson we are reducing radical expressions. Radical, that's a mistake. Rational, we'll get to radicals in a little bit, but I better get the topic correct. Rational, which means fractions. Now, before we can start to reduce fraction expressions or rational expressions, there's a few things we have to keep in mind. First thing is what a term is. Terms are a number or a variable. Okay, so 3 is a term and x would be a variable, or a product of a number and a variable. Okay, so even 6xyz squared, that thing is a term because it's a product of a number and a bunch of variables. Z happens to occur twice, so z times z, but we write it z squared. Okay, then a polynomial is something like 3 plus 4x, where you take two of those terms and add them together. Okay, here I've written just two-term polynomials. We call those binomials, but you could add a number of terms together. 4x squared plus 5x plus 1. That's a bunch of terms added together, and we call that a trinomial. But they're all polynomials. Okay, and then when we get to reducing rational expressions, we really have to understand what a factor is. Okay, so for example, if I write the term 4x, 4 is a factor of that, and x is a factor, because a factor is just something that's multiplied by something else to produce something. In this case, it produces 4x. The things that make up 4x are the 4 times the x. But I could even break this up and write it as 2 times x. Those still equal 4x. They produce something, and 2 would be a factor, and 2 is a factor, and x is a factor. So all of those are factors because they are things that are used by the operation of multiplication to produce something else. Okay, so where I think we get confused about this is if we look at the binomial above, 3 plus 4x. What's a factor of that? Well, nothing. Because to be a factor of this binomial, you have to be a factor of everything in it. I can't write 3 plus 4x as something times something. I can write this individual term as 4 times x, which means 4 is a factor and x is a factor of that term, but 4 is not a factor of that entire binomial. However, if I look at 5x plus 15, I can say 5 is a factor of it because it can be used via multiplication 5 times to produce 5x plus 15. So in this case, 5 is a factor, and so is x plus 3. And that's kind of a key thing to keep in mind. What's a factor and what is not a factor, and whether it's a factor of just a term or if it's a factor of the entire binomial. Now, to help us understand this, I've written a rational expression. It is a fraction, which means it's rational. Okay, it's a ratio of two things. This one, though, I have terms that are just integers. 3 plus 6, those are separate terms. Remember, a term can just be a number or a variable. Here they're just numbers. And on the bottom I have a different set of terms. And this is where we oftentimes make a mistake. People often think, well, first let's look at the correct answer for this. If I were to actually mathematically do this, it's 9 over 21, which is just 3 over 7. So any manipulation of this original expression has to be equal to 3 over 7. And so here is the expression again. And I'll see students oftentimes do this move. Oh, 6 and 6 cancel. And that's 3 over 15, and that's 1 over 5. Well, clearly 1 over 5 is not equal to 3 over 7. So you cannot cancel terms. And that's just a fact. Math does not work that way. Terms do not cancel. So forget about doing that. Let's look at what does cancel. What does cancel is factors. So again, here's the original problem. I'm going to do something unusual, what I wouldn't normally do if I was solving this problem. I'm going to say, hey, 3 and 6, both are divisible by 3, so I'm going to pull that factor out. 3 divided by 3 is 1, 6 divided by 3 is 2. And 15 divided by 3 is 5, and 6 divided by 3 is 2. And now, factors do cancel. This 3 and this 3 just make a 1, and I end up with 1 plus 2 over 5 plus 2, which is 3 over 7. It works when you cancel factors, not when you cancel terms. I couldn't, for example, I canceled the 3's right there. I can't cancel those 2's. Those 2's are terms, they're not factors. They're added on. We're looking for things that are multiplied together to make something. 3 times 1 plus 2, if I distribute the 3, gives me 3 plus 6. That means 3 is a factor of 3 plus 6. It also means 1 plus 2 is a factor of 3 plus 6. And the factors are the things that I can cancel when I simplify rational expressions. So here's an expression, a rational expression again. Now I've got a variable in there. Okay. Let's look at the factors of the numerator. Factors of the numerator are 3 and x. Those two multiply to give 3x. Factors of the denominator are 2 times 3. They multiply to give you 6. 3 is a factor of the entire numerator. 3 is a factor of the entire denominator. These 3's can cancel. So it just simplifies to x over 2, which is something that we've taken for granted over the years. We know 3 over 6 is a half, but this is the reason why. Once you start to understand this, it becomes a little bit easier. We can see on top we have all multiplication, 12 times x times 2, or x times x, which is 12x squared, and 4 times x. 4 is clearly a factor of the denominator. 12, I could factor that, but I know 4 goes into it. So that means 4 is a factor of it. So I simplified 12 over 4 into so that's a 3. And x squared over x, man, that is x times x. Those are both factors. This is a factor, so I can cancel one of those. And I'm just left with 3x for a simplified version of this original expression. Now, this is a different type of problem, and the difference is the previous ones all have multiplication, whereas this one has that big addition sign. So again, thinking about factors, 8 and n squared, those are factors of that term. 4 and n are factors of that term, but they are not factors of the numerator. The numerator is the whole thing. To find a factor of the numerator, I have to look for something common between the 8n squared and the 4n. I'm going to take a 4n out of each of those because I know they would be inside of them as factors. So I can check my math here. 4n times 2n is 8n squared, and 4n times 1 is 4n. So these two things multiplied together give me this original numerator. So they are factors. On the bottom, I think I can take out a 3n. 3n. And I'd be left with a 2n plus 1. Now let's look for common factors. 4's a factor, n's a factor, and 2n plus 1's a factor. 3's a factor, n's a factor, and 2n plus 1's a factor. Common factors can cancel. This simplifies to simply 4 over 3. And that's all we're doing. The key is you've got to get your numerator and denominator factored, then look for common factors so that you can cancel them out. Here's our final example. We got a trinomial over a trinomial, and this is the temptations you have to fight. This 6 and this 6, boy, you just want to cancel those out, but they aren't factors. They're terms. It's minus 6 minus 6. They aren't multiplied into the numerator or denominator. So we do what we did when we were solving polynomials. We factor these things. Now this numerator is pretty tough to factor. It's got a 3 sitting out front. So I'm going to factor the denominator first. P and P. To get a 6, it's got to be 2 times 3, or it could be 1 times 6. But I want a difference of 1p. Out here I get a 3p, and here I get a 2p. I'll make that one negative, and 3p and negative 2p have a difference of 1p. So that's my middle term. The reason I did the denominator first is because it can sometimes help me factor the numerator, or vice versa. To get 3p squared, there's only one way, 3p and p. 6, on the other hand, could be a 1 and a 6, or a 2 times 3. I'm going to go with 2 times 3 because I have those in my denominator, and if something's going to cancel, it's got to match up with one of the factors down there. So let's take a look at that. I think I'll put the 2 there and the 3 there. Outside gives me 9. Inside gives me 2. 9 and 2 have a difference of 7. I'll make the 9 positive and the 2 negative. That will give me a 9p minus 2p, which adds up to 7p, and the negative 2 times the 3 give me a negative 6. So there's my factorization. Okay, these two binomials in the numerator multiply to give me the original one. That makes them factors. These two down here multiply to give me the original denominator. That makes them factors. These are common factors between the numerator and denominator, and therefore I can cancel them out, leaving me with that simplified result. And that is how you simplify rational expressions or reduce them. Just factor them, look for the common factors. Every time you get something in the numerator that matches the denominator as a factor, that just makes a giant 1. Same numerator, same denominator. You got the whole pie right there, and you're done. Hope that helps.